Hello, class. Okay, so this week we are studying uh, math functions, chapter 14. So I'm going to go ahead and give you guys just a little bit of instruction on how these work in case you had some trouble understanding it from the chapter. So first off, what we're going to do is we're going to look at add, subtract, multiply, and divide are your basic functions. The book shows those add, subtract, multiply, and divide. Just ignore the less on page 266 for now. We'll get to that here in a minute. But on page 268, it shows a compute, which I will talk about at the end, and clear. And then the last thing it shows on page 270 is a square root and an x to the power of y. This processor actually does not have the x to the power of y, so we won't be looking at that. All right, so I have my emulator running in the background with my math program loaded into it. I have my RS links running in the background with the emulator hooked up. And I have my math program demo loaded into my SLC 500. And you'll notice that I am offline. You have to be offline in order to make programming changes. So I'm going to add a rung. I'm going to add an input 1.0/0, and that's going to be activate add. Okay, and I'm going to go to the math tab here, and I'm going to add a add command. Now you notice that the input's on the left hand side, the add's on the right hand side, and that means that the input is a condition, the add is a result style, and you see where it says that it needs a source A and a source B. And we're going to go into the math monitor. You can see here, here's all of the program places where I want the data to go. Source A for the add is going to be N70. So that's N70. And that's an integer file. And that's going to be, let's just make that add source A. Okay. Now why is that an integer? Well, because we're not going to be putting in any decimal values or values after the decimal point. So we can use an integer file. That means it's a whole number without decimals. And so N71 is going to be our source B. And we can edit that description and call that add source B. Say OK. And then our destination, we're going to put that into N72. And we're going to call that add A to B. And hit enter. And you'll see that it takes that description and puts it up there. Now if we go into our custom data monitor, or custom graphical monitor, you can see here that it's going to add N70 to N71. It's going to store the destination to N72 whenever I press this button. I noticed earlier that when I run this, it will show these all listed as 10. So if you see that, don't get too excited about it. All it is the properties need to be changed to match the input number. And I'm going to go ahead and do that now. That should actually be a 2. That should actually be a 3. I will save this before I, this should actually be a 4. This should be a 5. And then this one should be a 6, and it is. Okay, so now when I run it, you'll see that the input numbers match. All right, so on here, oh, I haven't on your program, before you can run it, you have to verify it. You can either click Verify Project up here, or you can right-click in the red area and do Verify Rung. Either way, Verify Rung will do it one rung at a time. Verify Project will do the whole thing all at once. But once it's verified, now you can download it to the virtual processor. Okay. And put it into run mode. All right. And now on your graphical monitor, you've got the monitors in run mode, and we're going to put it for source A. We click in that window and this little keypad pops up, and I'm going to put in a 25. And you'll see now source A says 25, and you'll see over here in the rung, it shows N70 now has a number 25 in it. I'm going to put in for source B, we're going to put in 15, hit OK. And now source B shows a 15, and source B, N71, shows that it now contains a 15. And now when I press the activate button, you'll see that this input will come on and this calculation will be performed. Okay, you see how that input is turned green, and now over on this side over here you can see that our destination is filled with 40 because 25 plus 15 equals 40. Alright, I'm going to go ahead and stop my custom graphical monitor, and I'm going to add another rung. I have to go offline, save changes. In order to add a rung, I'm going to have to go, you know what, I'm going to go ahead and leave this on the math, and I'm just going to right click here and insert a rung. And I'm going to copy and paste that input and change this from 0 to 1, and we'll call that, actually hold on, cancel that. Let's go into our graphic monitor and see our divide is the one we want to look at, and that should be a 3, 1, 3. Should be 1, 3. And that will be activate divide. Okay. And so now we're going to bring down our divide operator down here. And we'll look back on our graphic monitor, and for divide we need N710. And for source B is going to be, let's move that over just a little bit. N710 for divide, I'm sorry, N710 is source A, source B is N711, N711. And our destination is actually, it's going to be in the F8 file or floating point file, F80. Now, why is that? Well, that's because a lot of times, and that's going to be divide A by B. Because a lot of times when you divide two numbers, you're going to get a decimal point. So you have to use a floating point register so that it will keep that decimal point. If we save that into another integer, it would lose whatever's after the decimal. So in order to keep the whole calculation, we have to use a floating point or F8 file. Now I'm going to accept that, verify the rung, and you see it says everything's cool. And we're going to go download to the processor. Go online, yes. And make sure you put it back into run mode. And now let's fire up our graphical monitor again. And when we enter 25, and let's make it divided by 5. 25 by 5, and when I press the button, you'll see that this will, oops, I put it in the wrong spot. 25, 5, there we go, that's divide. So when I press 1, 3, you'll see that this input will come on and the calculation will get made. Alright, now 25 divided by 5 is a nice even number. There's no decimal points, so the 5. But you'll see that the floating point automatically says I'm going to have at least one decimal point even if it's a 0. So it shows up as 5.0. Now if I change this 5 to a 6 and then hit the divide button, you'll see that now it shows 4.1666666, so on and so forth to infinity. And that's the way the floating point works. All right, I'm going to turn that off. And the last thing we're going to do is I'm going to go back offline, save changes. Yes. All right. And I'm going to add a rung. And I'm going to do x squared from our calculation of a triangle, side a squared plus side b squared equals side c squared. And if you remember from math class, that means that c equals, this is what I'm using for square root symbol, square root of a squared plus b squared. So that means that what we need to figure out, let's take rid of this because this doesn't actually work. We need to figure out is source A times source A plus source B times source B, and then take the square root of that sum to get C. Okay. So how would we do a squared plus b squared? Well, first of all, let's figure out how we're going to do a squared, first of all. All right, so I'm going to put in another input, and our custom graphical monitor says that our input should be, oh, it's gone. That actually should be 6. Okay. All right, so it says it should be 6, so we need input. Oh. Paste input 16, and that is activate triangle calc. All right, and so what we can do is we can use a multiply, and we can say source A from our graphic monitor is source A is N730. So N730. And we can use the same thing here, N730. What that does, it takes A times A, and that's an easy way of doing A squared. Or, you know, A times A is A squared. And then in our destination, we're going to store that into N740 because we know that that's a nice open spot, and we don't have to use a floating point because any whole number times itself or any other whole number is going to result in a whole number, no decimal. So we can store that back into an N7 file. Now that, since we're storing these in N7 numbers, we know those are going to be integers. All right, so we can go up here and we can do verify project. And you'll notice that it cleared up both of these rungs here. And now we can download that to the processor. All right, download, yes, okay. Now we can make sure and put it back into run. Start up our graphical monitor. And if we put in 5 here for A, now notice we haven't done anything with B yet, but we put 5 in for A, and you'll see it says 5 here and 5 here. And so when I hit our input button, There we go. 5 times 5 is 25. And there we go. So now I'm not going to do the rest of the calculation for the formula to find the hypotenuse of a right triangle. That's going to leave that up to you guys to figure out. So, figure it out. These are going to be your two inputs for side A and side B. This is where I want your side C. That shouldn't be an N7 file. That should be a floating point. That should be an F. That should be an F81. There we go. All right, so side A, an integer. Side B, an integer. Do your calculations, store the result in side C. All when you press this one button. That's going to be your homework to figure out and turn that in by Tuesday. I'm pretty sure that the book gives you pretty much the same thing, but this is just a practice. Now, I said that at the end of this I would talk about the compute statement, and I'm going to go ahead and go offline and save. All right. Now, you could use a compute statement here, but that's not what I want you to do, so don't do that. But if you use a compute statement, what you can do is you can tell it just where do you want it to go, F8, and where was our destination? F81. And then in the expression, you can actually type out the whole formula N7, and it was N730. Times N730, and that would get you A squared plus N731, and I think it will let you use the caret for squared, and then you take the square root of the whole thing, and let's see if that will verify wrong. Invalid expression, too many closing parentheses. N7. Yeah, I think it doesn't like this. So we'll have to do 731 times N731, and let's see what it says about that. Still says too many closing parentheses. What the heck? But anyway, let's see. Let's take this out. And see if it'll verify there. Yes. Okay. So what this shows is that you can type in a formula of, a whole equation in here, and it will compute the whole thing and then store it into this destination. But like I said, I don't want you to do that. And a lot of times, unless you have a really complicated compute statement, it's better to do it in a step at a time. So that's your homework. Figure that out. And then when you click on the custom graphic monitor, when you click this button right here, it should take your side A, your side B, perform the calculation on it, and then store the result inside C. All right. The last thing we're going to talk about is the CLR, which is a lot like the RES for the timers and the counters, and all it does is it takes one argument. I'm going to delete that. Come on. Delete that, and CLR. Not sure where it is in there, but anyway, it takes one argument there, and you can put in any word, and all it does is it takes that word and makes it a 0. So, just clears that word out, just like resetting a timer sets it back to 0 or whatever. Resetting a counter sets it back to 0. So that's it for this. If you have any questions, email me or use Canvas and let me know. Thank you very much.